Good morning to everyone. Today I'm going to present our recent study focused on structural and diagnostic investigation on materials and plasters of the Biblioteca Umanistica of the University of Florence. This project is performed in collaboration with University of Florence, and here are present some preliminary results obtained by investigation carried out from March to July in 2021. I'm going to discuss about a brief historical background of the monument for first, then a small introduction on structural and geophysical surveys which were performed. I will focus the second part of this presentation on the diagnostic approach used for the characterization of colored plasters collected from some areas of the monument surface. The Biblioteca Umanistica, which is literally the Library of Literature Studies of the University of Florence, was built in 1295 as a monastery, which became a prestigious place equipped with cloisters and noble chapels, and becoming a main center of miniature and pictorial art, even by placing big works of art of very important artists as Masaccio, Paolo Uccello, Beato Angelico, Lorenzo Ghiberti, and even Brunelleschi worked there. The original part of the ancient monastery is the area highlighted in blue color on the image, while the others were realized in times after the date of construction. We are focusing on this ancient area for the diagnostic investigation reported in this study, and in particular, three main areas were considered, which are the main cloister, the part which comprehends some rooms and corridors, and the small cloister, named as Nigetti cloister. Structural and geophysical investigation performed are based on combined techniques including preliminary endoscopic investigation, GPR survey, and geoelectrical survey. They have allowed to verify if there are any structural and underground discontinuities, both in the monument's wall construction and into the underground profile, respectively. In particular, video endoscopic inspection have allowed to identify some interruption, occlusions, and ruptures, while by GPR and geoelectric surveys in the underground network was mapped, even by defining the location and the extension of infiltration phenomena. Reporting as an example, this resistivity profile reconstruction, it was obtained by geoelectrical survey, which was carried out in correspondence to the Nigetti cloister, the smaller one. It is clearly shown a large area affected by infiltration phenomena. Here is indicated in blue color. This was also defined by GPR acquisitions related to the anomalies found and attributable to the complex system of pipes network present in the subsoil of the structures. The diagnostic approach related to the investigation of colored plasters was performed mainly by using optical microscopy and FTIR techniques, aiming at the investigation of the stratigraphy succession and the characterization of the plaster matrix. In particular, three interesting samples were considered and are respectively C12, collected from the main cloister, C6, which was collected from a vault lunette from the corridor, and C14 from the smaller cloister, the Nigetti cloister. The plaster sample C6 was collected from this vault decoration, and it might represent a vine branch with some grapes. From the microscopy observation, a succession of 4 layers was observed, including a line-based matrix for each layer. In particular, above the plaster substrate were visible a white preliminary layer, the number 3, and a subsequent pigmented layer, number 2, with a pinkish to yellow color, probably related to the yellow found color and the orange reflects details of the painting that are shown in the photo on the left. Above them, an interesting dark pigment used for the vegetal item was observed, and it was analyzed by FTIR spectroscopy in order to understand its composition. As we can see from the FTIR spectrum, this is related to the use of the green earth pigment, which was widely used by artists in Florence even before Renaissance. It is constituted by calcium carbonate, gypsum, and some silicates and oxide of iron, aluminium, potassium, and manganese. Then a huge amount of calcium oxalates was detected, made due to an organic binder used or may be related to some restoring intervention. Obviously, further studies are absolutely necessary to understand this aspect. As for samples C12, which was collected from the main cloister, from the microscopy observation we can observe a succession of two white carbonate layers placed above a pinkish lime-based plaster matrix, including some rounded aggregates. In addition, some sample fragments have shown the presence of vegetal fibers. This is quite interesting. Actually, we were able to see them firstly by using UV reflecting light mode, which have led to a fluorescence response of the organic matrix. Then, by using FTIR technique, we observed the vegetal nature of these fibers, reporting a typical cellulose absorbance band, comparable to fibers of flax or hemp, which are very similar each other in the structure of the bundles. Finally, sample C14, which was collected from the Nigeti cloister, have reported a succession of 4 white layers placed above a lime-based plaster matrix, including mainly silicate aggregates. Even in this case, the presence of oxalates was observed, not clearly attributable to some organic binders use or for recent restoring intervention performed. As previously mentioned, further studies are necessary in order to study this aspect. In briefly conclusion of this presentation and our research, it was confirmed the importance of a multi-analytical approach for the conservation of historical monuments, in particular by including structural and archaeometric investigation in order to obtain important information on their degradation products and property of materials and giving a contribute for future restoration plan and some maintenance activities. Thank you for your attention.